Buried beneath your feet lies an ancient library with chapters written not in ink, but in stone. Each layer tells a story spanning millions of years of extinct creatures, vanished oceans, and climate catastrophes that shaped our world. Today we're cracking open Earth's geological diary, sedimentary rocks. Sedimentary rocks are one of the three main rock types formed through accumulation, compaction, and cementation of sediments over time. These sediments come from a breakdown of pre-existing rocks due to weathering and erosion, biological activity, and chemical precipitation. The process occurs on Earth's surface, primarily in water bodies like rivers, lakes, and oceans, where sediments settle in layers and undergo lithification, which is the transformation of loose material into solid rock. In this video, we are going to learn about the three types of sedimentary rocks, learn a little more about the processes involved in their formation, and discuss the significance of these rocks. Let's start with the three types of sedimentary rocks. Sedimentary rocks are classified into three main types based on their origin and composition. Clastic sedimentary rocks are rocks that formed from the physical fragments or class of other rocks that are transported and deposited by wind, water, or ice before being cemented together. Examples include sandstone, which forms from sand grains, shale, which forms from clay and silt, and conglomerate, which forms from rounded pebbles and gravel. Chemical sedimentary rocks form from minerals that precipitate from a solution, often due to evaporation. Some examples include limestone, which forms chemically from the precipitation of calcium carbonate from lakes or ocean water, and rock salt, which forms from the evaporation of seawater. Organic or biological sedimentary rocks form from the accumulation of plants and animal remains. Examples include coal, formed from decomposed plant material in swamps, and chalk, which is formed from microscopic marine organisms like foraminifera and coccolithophores. So now we know the types of sedimentary rocks, but what are some of the processes that are involved in their formation? I'm glad you asked that, because now it's time to talk about that exact thing. One of the most important processes is weathering and erosion, which is when rocks break down into smaller particles due to mechanical or chemical processes. We covered these more in depth in my rock cycle video, so check that out if you're looking for a longer explanation. Another key process is transportation, which is when sediments are carried by rivers, glaciers, wind, or ocean currents. After transportation is deposition, which is when the transporting medium loses energy, sediments settle in layers, and they create strata or bedding planes. Finally, we have compaction and cementation. Over time, layers build up and the weight of the overlaying sediments compresses them. Minerals like silica, calcite, and iron oxides act as cementing agents, binding the particles into solid rock. Okay, so now we know how the rocks are formed, but why do we care? Well, sedimentary rocks are essential to understanding Earth's history as they contain fossils that provide insights into past life, climates, and environments. Sedimentary rocks serve as natural archives of Earth's climate history, preserving evidence of past environmental conditions, atmospheric compositions, and climate changes over millions of years. By analyzing different characteristics of sedimentary rocks, scientists can reconstruct ancient climates or paleoclimates and understand how Earth's climate has evolved. One key method involves studying sediment composition in mineralogy. For example, the presence of evaporites, such as rock salt and gypsum, indicates hot and arid conditions with high evaporation rates, while coal deposits suggest warm, humid environments with less vegetation, typically of tropical swamps. Similarly, glacial tillites, sedimentary deposits left by glaciers, reveal past periods of extensive glaciation, such as during ice ages. Another crucial approach is the analysis of fossils within the sedimentary rocks. Microfossils such as foraminifera and pollen grains provide information about past temperatures, precipitation levels, and vegetation types. By examining oxygen isotope ratios in marine fossils like shells and corals, scientists can estimate past ocean temperatures and ice volume. For example, higher oxygen 18 levels in carbonate shells indicate colder periods with extensive ice cover. The study of sedimentary structures and layers, or stratigraphy, also helps in climate reconstruction. Varves, which are seasonal layers of sediment deposited in lakes, provide annual records of temperature and precipitation changes. Loess deposits, which are wind-blown dust, indicate past periods of strong winds and dry climates. While red beds, which are iron-rich sedimentary rocks, suggest the presence of oxygen and arid conditions. By integrating these methods, sedimentary rocks allow scientists to trace major climate shifts, such as the transition from greenhouse to icehouse Earth, past droughts and monsoons, and mass extinction events linked to climate change. This research not only helps in understanding Earth's past, but also provides insights into the future climate trends by comparing past natural fluctuations with modern human-driven changes. Short answer, rocks can tell us a lot. They also play a major role in natural resource exploration as they host petroleum, natural gas, and coal, key energy sources. Groundwater is often stored in sedimentary rock formations, making them critical for freshwater supplies. Economically, they are widely used in construction, like limestone and sandstone for buildings, industry, like using gypsum for plaster, and manufacturing, like using rock salt for chemical processes. Rocks are extremely important for not only science, but also our day-to-day life, and some may say that sedimentary rocks are the most important. I hope you guys enjoyed this video and learned a little something. If you guys made it this far and could like, comment, and subscribe, that would mean a lot. It lets me know that you guys are enjoying these videos. Thanks for watching, and as always, you guys rock. Peace.